in smart contracts. So this is actually really an interesting technology in that we do have a lot of paper. We generate a lot of contracts every day. Everything is written down, and we have the ability to go through and basically track and trace it as long as you know where the documents have been stored. So we have paper wills. They're going to be stored by a lawyer or by something else that's online. Inheritance, all this stuff can be made digital, relatively easy. Wills and inheritance are pretty standard work right now. Most of us don't have anything to pass down. And for people that have hugely complicated ones, they've got a bevy of lawyers working for them. But again, you can use and store these within the blockchain network and just basically be able to be how to pass your assets down as you pass away, and put your end of life concerns to rest. But there's more to it than just that, right? There's more to it than just paper wills. If you think about what smart contracts really are, they're essentially automated agreements between content creator and the recipient. And if you think about all the other lectures here, right, we've talked about supply chain, we've talked about food and food safety, we've talked about healthcare, we've talked about education. All of these are essentially contracts. I contracted with the college to teach a certain amount of classes, or a student went in, they contracted with the college to get a certain degree, and money was paid, and you could actually put your smart contract, your degree or your skills list or your diploma into this, and it would be considered a smart contract. And again, it's basically the agreement is baked into the blockchain, so making it immutable. As long as you can prove you have earned that piece of paper. You've earned the commitment to that whole process, whatever was in that contract. And again, you can use it to automate the execution of agreement, so that if I do a thing, you'll pay me, $100 million, and I win the lottery, and everything will be good, without the need for intermediaries. As long as it's triggered somewhere in the process that I'm going to work for $90 an hour, and I'm going to work 100 hours a month. I'll get paid that as long as I can prove I did that 100 hours worth of work a month. You can also use it to automate your workflow, starting when certain circumstances are satisfied. So if you're writing code, if you are doing documentation, if you are doing something along the way that requires a hand in or a hand out for all of my program manager followers, you can actually use that to automate the workflow. I turn something in, I have it go through whatever checks and balances, pre-fast, post-fix, whatever, to make sure the code was clean, or this document had to be returned. And if I did that, then here, pay me my money, or get through and let me download the next set of code, or whatever I need to do. You can think about this in terms of something like more gig work here, would also really, really handy, because you are paying per piece. And as long as the piece is turned in and accepted, you can just go ahead and just, you trust me to do a thing, and I do it, and then you pay me automatically. So with conventional contracts, though, we're kind of just doing our thing. It basically outlines the terms of relationship between two parties, and that's enforceable by law. So that's the big thing, right? If one party violates the terms, party B can take the other to court for not complying with the agreement. If you take a look at something like a college syllabus, that's actually a contract, believe it or not, between the institution and the student, that these are the things you will be presented to learn, and this is how we will enforce that learning, or you'll take these tests to prove you learned a thing. Any kind of contract can be done with that. I've actually seen lawsuits over syllabuses, which is really kind of interesting. But again, it's that idea. Party A and Party B, we're going to agree to do a thing. And if someone doesn't do it, then I get to take you to court and to try to get the contract enforced, or try to make myself whole again by getting money from you. So how do smart contracts work? So Cointelegraph had this really interesting graphic on their website about how this actually works. So when you're building it out, you're going to make the agreement. I agree to do a thing, and you agree to pay me a thing for that, or we both agree to do a thing to accomplish this other task, right? Whatever conditions are on it, like we'll only work 10 hours a week, or 40 hours a week, or 100 hours a month. And then any kind of coding that goes into making sure that that's actually written down and clean and concise, because contracts really do need to be clean and concise. Then it will get dropped into the blockchain. It will be made part of the permanent record, and then the contract will be executed, and then the recording of the outcome, the output, whether that output was met or not met, or if it was met, you get certain things, or however it works. But that execution stage is after the contract has been put into the ledger. And then once that contract is completed, you just record that the contract's been completed. You're pretty well good to go, right? So you can really just break this down to a couple of steps, right? When you're going to have an agreement with between two or more parties that stipulate a thing, Right, once established, the two can agree within the conditions on that smart contract to be considered complete. So a KPI or a percentage complete or a customer sign off on a step or whatever you need to do to make sure it's considered complete. And then all that would be written into the smart contract, then encrypted and stored in the blockchain. It could be done open, it could be done encrypted, it could be a link to a DocuSign or something else, right? It doesn't necessarily need to be the full contract. It just needs to be a way to access the data in one form or another. I'm a big fan of links. If you take a look at the US passport system, it's essentially an RFID chip in your passport that points to a link to a database on the government side that then gives you all the information about the person holding that passport. So again, just kind of a neat thing. So you could do that within a smart contract very easily. So once the contract is complete, the transaction is recorded in the blockchain just as any other thing would be done. And then boom, everything's done. Everybody gets paid. Everybody's happy. So again, fairly straightforward. Now the big difference though between a contract and a smart contract I thought was also interesting. So Cointelegraph had this neat graphic about what is the difference. So written contracts and smart contracts, right? So language code, and by that they mean human language, a written contract, human. If you believe that lawyer language can be human language, then you're doing fine. Machine computer code, that's where I'm more comfortable. So I would be able to probably read it as machine computer code more than lawyer code. Automation, you can do all or parts of the agreement, and then only the transactions can be automated in a smart contract. In a written contract, conditions can be written on paper by the concerned parties, but in a smart contract, all those conditions are basically built into the contract itself. So again, conditions are an interesting thing. What constitutes acceptance of the project, and then modification of an internal state. So you could actually modify a written contract, but the smart contract as is generally immutable because it's written to the blockchain. But that doesn't mean you can't do an addendum. So you could do addendums to smart contracts. It's just more paper, where in a written contract, you would just make a modification or an addendum. So there's ways of changing it around from that written contract versus a smart contract. You would just need to have a tracking code or some way to be able to write out how that contract was written, and if there are any later on addendums to that, to make sure that everybody was satisfied with the process. Now again, there's some various benefits to having a smart contract, and including speed. I can get things done a lot quicker. If I am a farmer and my contract is to supply 100 pounds of bananas, and I supply 100 pounds of bananas for $50, as soon as that 100 pounds of bananas is registered, I get paid my money. I'm good. Right, that speed, boom, we can make things very efficient. We can make it very accurate. 100 pounds of bananas, X amount of dollars, right? Trust, transparency, right? So I trust you because you probably have that money in escrow. I would ask for escrow. And as soon as I deliver, it comes straight zooming out of escrow. So there's some trust there and some transparency. I know the money is available. There's some security. I know that if someone was to come back and say, well, you didn't give me 100 pounds of bananas, I could go and say, well, I actually did. And here is the record that shows I did the thing. And then there's some savings because it's all automated and things are flipping back around. There's no humans involved here. As long as everything is clear and concise and machinable, then you can get some real cost savings out of it by pulling the human out of it. There's going to be some audits that need to happen along the way. But in general, the more you can pull humans and human weirdness out of the solution, the better off you're going to be in terms of savings. So smart contracts use computer protocols, right? Again, that whole process of what we do with DocuSign or anything else that we do contracts with. You can save hours because you can use templates. Food production, especially on food production and delivery, the conditions are pretty straightforward. So you can save a lot of time by just using standard templates. So again, these automated agreements decrease the possibility of third-party manipulation, and it removes the middleman. And that's a good thing, right? The middleman, again, we all have price markups. So again, the lack of an intermediary, though, really can save some money because everyone's going to mark up on top of everything else, right? That 20% administration fee is no joke. That actually really happens in the contracting world. So the farmer gets 100, the producer will sell for 120, then the next intermediary will sell for 150, and by the time it gets to the grocery store, it's like around 200. The price is doubled, depending on how many intermediaries are in there and how much that administration fee is. For some people, that margin may need to double the cost of the product to get it into the hands of the consumer, or maybe triple it. Depends on what your retail looks like and where you're at, subscription models and everything else. But removing intermediaries could save the consumer a lot of money or increase the profits of the company that makes the product. You could actually probably do middle ground here. I'll increase my profits because I'm removing the intermediaries. So I'll sell for a little bit more and it will still look like a deal to the consumer because I'm saving them X amount of dollars. So those benefits to having a blockchain contract actually make a lot of sense, right? So you can keep everything on the blockchain and everybody can go back and track it depending on what you've got. You can encrypt them, those documents, to make sure the documents are not tampered with. But again, I think one of the things that I'm seeing more in this process is that we're pointing off to a pointer. So we're pointing off to something like a DocuSign document or some other document storage process. So the document isn't necessarily inside a blockchain. The blockchain just holds a pointer or a link to it, and everything is done through an ID, digital ID. So there's some real applications here, right? And ones that actually make a lot of sense. So in your identity, in your ID, if you could do something with that. Real estate, I see a huge good boon for real estate, because if you remember the 2008 housing collapse, one of the things that really caused a problem was that no one could find out who actually owned the property. No one knew who actually owned the title of record for those properties, and that turned into a real disaster when people were getting foreclosed upon. If you remember that people were going back through and saying, no, have them produce a title, and companies couldn't produce titles to these houses. So real estate, if you could actually track the title of who actually owned the property, what a boon, right? Insurance, you could just go ahead and do a pointer over and here's all my insurance. Mr. Policeman for pulling me over for doing 100 in a 45 zone. Supply chain, it's pretty standard. You're going to see all this across the supply chain. I'm going to deliver X amount of product to you for X amount of dollars. You get the product, I get the money, everybody's happy. So again, there's some really straightforward things in here that will make life a lot easier if we're working in this space and doing the process the way that the blockchain promises. Now, there's some real challenges here. Human error. Oh man, human error is always possible, and it could lead to exploits. And that's exactly what happened with Ethereum's decentralized organization, right? Hackers exploited a vulnerability in DAO's fundraising, and boom, they were able to get funds from the project because they were able to alter the process. So again, there's also a lack of regulatory clarity when it comes to these anonymous agreements. You know, is it really enforceable and or taxable, or do we really have the right things at the right time? So without having regulation around this, you end up with a really big freewheeling environment that can be used to exploit it. All right, so smart contracts can't pull information outside of the network in which they exist. So everything ends up being in silos, and that could be problematic for some people, right? Not necessarily for companies. Companies want to keep their contracts in the silos for their own needs and purposes. No one wants to know how much people are being paid for access to resources or anything else. So at least not in their current state, it's going to be really hard to try to get a level set balance outside of those silos for smart contracts. You can't upload data from an existing website into a smart contract on Ethereum, but you could probably do a pointer really easily. And again, that's where the idea of using pointers rather than actual records may actually help out here. And then there's a workaround with this, and that off-chain nodes can pull information from the internet and make it compatible with blockchain networks. So that workaround, okay, but it's more or less going back to the idea of using a pointer and then having to massage the data to make it compatible with blockchain. And eventually, as databases move into the blockchain, oracles could potentially step in to play a role to making that happen. Because as long as we understand what the data definition language looks like, or we understand what the base contract looks like, there's things that we can do to work around that process so that everybody understands what's inside that contract and where it's being stored out and how it's being used or shared or otherwise enforced. And then the other one is scaling. And we have talked about a lot of scaling issues in module 1 of this course. So since inception, blockchain networks tend to struggle at scale. They just simply do. Especially if you look at Bitcoin, if you look at Ethereum or others, you can have some real interesting challenges when it comes to that. So there are people in there that are using hyperledgers like IBM. You've got other people that are changing the game when it comes to some of these challenges. So you've got Ethereum 2.0 that's trying to look at this problem. And again, anything that can shorten the amount of time it takes to get this process going or approved or otherwise just makes things easier, right? We're used to having near instantaneous transactions with Visa when we go to the grocery store. We want to see the same thing in our contracts. So there's some really interesting future portion of this that goes along with it. So you've got some really smart requirements powered contracts. They're undoubtedly the way forward. And that's the neat part about this, right? As long as you can get standardized contracting in place, you can make this Bitcoin or blockchain enabled smart contracts a lot quicker, whether you're putting it in the Bitcoin network, or you're putting it in the Ethereum network, or you're putting it into IBM's Hyperledger, or you're putting it into something else. It's all there, right? So various smart contract platforms can save businesses worldwide time and money. And that's a big one, right? Worldwide, I can make sure that if X happens, Y happens. If I do a thing, then my customer internationally will get a thing. We can find out if there's hitches in the supply chain, and we can do things work around with minimal human involvement, right? And that means we can go to being a decision maker for those exceptions rather than having to do the day-to-day administration. So a neat thing about that smart contracts is that it's being used by banks and insurance in their daily operations. And again, when you're doing DocuSign, there's no reason why that DocuSign cannot go into a blockchain network. So we're getting there, but we're still working on it. And again, it's got a long way to go until we get here. So who's in this space? We've got Ethereum. We also have IBM. So no surprise that there's IBM. But what I thought was interesting about Ethereum is that basically they're doing their distributed applications, and they've got it all set up based on some really old data, right? They started thinking about this 25 years ago at the time of recording of this. So the idea of that smart contract, right, was done by Nick Szabo as kind of a digital vending machine, right? And so interesting on that and how he chose to approach that process. So a simple Ethereum contract, a user sends a friend 10 Ether, but requires that it can't be dispersed until a certain date using a smart contract or until a certain condition actually applies, like something happened or something was done. So Ethereum, though, really kind of allows you to do a number of different things, which I think are kind of fun. You can do multi-signature accounts. Funds can only be spent when a required percentage of people agree that the conditions were met. You can do encoding of your financial agreements. You can manage agreements between users. Say if one person buys insurance, then the roles of the insurance can be redeemed, can be programmed in a smart contract. So if I buy car insurance and my car gets totaled, and I can prove my car gets totaled, then the insurance company can just go ahead and pay that out without having to go through a lot of fuss or muss, especially on things that are really simple, like cars and otherwise. Agreements can be based on outside world, so you can pull in data from outside world. And again, my favorite idea here is DocuSign, right? DocuSign as a pointer system inside the blockchain would work really, really well. And it's a neat idea if you could make it go and you could get DocuSign to do that. And there's a reason to do it, right? You can provide for third-party software library links. So smart contracts can work with other smart contracts in a chain. So you could actually cascade contracts to do a thing. So if condition A is met, it means condition B is okay. It means condition C, D, E, and then cascade down so everyone is happy. And then there's storage, right? You can store information about the application, such as their domain registration or otherwise, into the blockchain like Ethereum. And it's unique that the idea is mutable and can't be erased, but it would be kind of neat if you could do this if you were doing a domain registration and you bought a domain and then someone came along later on and said, hey, I want to buy that domain from you. You could actually then go ahead and pay your money in Ethereum and be able to go from there. And it would all be stored off in the blockchain, so we know who actually owns that domain. And I think that's going to become a much more important part of the future as we look at where we're going with a lot of what's happening on the internet now, especially with freedom of speech, law enforcement, and a bunch of other things. So IBM, of course, right? It's all based on their hyperfabric. And again, it's similar to what they're doing in healthcare, food, and supply chain. So it's a producer to consumer process. So everything is checked in at every step. And again, the common dashboard and reporting. The thing I thought was interesting about IBM, though, is that this is one of the few things that they actually have on GitHub. So there are actually code on GitHub, whether it's legacy or newer processes. So you can actually go in and take a look or actually write your own distributed application on that IBM fabric. So it's really kind of a neat thing that they've actually started including code that you can actually go play with. So IBM is kind of jumping up on the game here and making code part of the process so you can actually program your own smart contract or your own smart contract system. And then finally, the big one is enforcement. So smart contracts are intended to live outside the legal system because they're enforced automatically, but they're a contract. And contracts go to court on a really regular basis. So that means that they're going to be coming back into the legal system, whether they're enforced automatically or not. So if they work the way they're supposed to, everyone will be happy. The problem is when contracts sometimes go wrong. All right, I'll think that I completed a contract and I'll think I did a great job and I will want to get paid for it. But my consumer, the person I did the work for, is like going, nah, Dan, no, this ain't going to work for me. So they want me to make a bunch of changes that may or may not be part of the contract. So they may say, look, I know we told you we wanted the screen to be green, but now we want it to be blue. So that's a scope creep, that's a scope change, but they could literally hold that up because they're like saying that they're not happy with the entry screen. So as long as everybody's good, we're good to go. But everybody knows the contracts go to court on a regular basis. So we don't know how enforceable they're going to be. Right. That said, many wonder how these contracts would be treated under the current legal system. Right. And there's some really interesting research on this. Levy and Lipton determined that U.S. law should recognize smart contracts. But, man, lawyers, they're going to do their own thing. And everyone's going to come up with different opinions. There is never going to be one solid opinion. So some courts will say, yes, this is enforceable. Other courts will go, no, this is not enforceable. And even all the way up to the Supreme Court, we're going to have differences of opinions, whether it's through the circuit, through the Court of Appeals, through Supreme Court. This is unsettled. We don't know if they're going to be actually truly enforceable and if there'll be a consistent message across the legal landscape. And given the current situation that we have with law, there probably won't be. There will be always an exception to everything. So every country has different legal approach to cryptocurrencies and blockchains. So that's another problem. Just because I write a contract in the United States doesn't mean that that same contract will carry the same weight in Kampuchea. So that's an issue, right? Especially if I am working in fashion and design and I own a workshop in Bangladesh. What do those contracts look like? Well, are they enforceable in Bangladesh like they would be enforceable in the United States, whose law applies? So we do have some really interesting questions about enforcement, especially on boundaries, international boundaries, and even just in the United States. There's very little test data on this. There are very few things have gone to court. So as we go and more contracts need to be settled in court, it will be interesting seeing how this actually works out. But the data just isn't there. So again, enforcement's an issue when we need to look out for, and you need to be prepared to lose. You may actually lose. There's no reason why your DocuSign agreements can't go into the blockchain, or at least a pointer to your DocuSign to at least have some kind of historical record on these and a way to verify that the process was done for automation. Right? IBM and Ethereum are really both in this space and really driving the car. They are working really hard on expanding this technology out. Both are equally good. Both have equal problems. There's code in GitHub if you want to go check it out. If you want to write your own decentralized application, your own DApp. And again, there's benefits, but there's also risks, data leakage. Not all contracts should be public, encryption, security, confidentiality. There's a lot of things that still need to be solved out for that just haven't been done yet. So neat things all the way around, and having smart contracts really does look like something that could be done. It's just there's a lot of space here. There's a lot of problems that still need to be solved. So there's a lot of room in here for people to help set those standards and set the guidance. But you're going to also want to work with lawyers on this one. The legal side of it is probably the more important. The technological side's relatively straightforward for solving out. It's the social and legal issues that we really need to face. So if you had a lawyer that was actually really good and really understood technology, this would be great for someone working with technology on the legal side to start setting those precedences for enforcement and privacy and confidentiality and encryption, working with IBM and Ethereum to really get more certainty in this space. Okay, folks, that's it for this lecture in smart contracts. I will see you in the next lecture.